Good morning, good evening, good afternoon, boys and girls. Let's start with today's lesson. It is one of the most and essential lessons. We are going to learn about the OSI model versus TCP model. So, at the beginning of the network chaotic time, all the vendors have their own standardization per se. We have IBM computers, and they were not able to communicate with HP computers, or HP computers were not able to communicate with Apple computers. So this is what happened. To fix this problem, in the International Organization of Standardization, ISO, re- research um, different network models, and the result is the OSI model, which was released in 1984. Nowadays, most vendors build networks based on OSI model, and hardware from different vendors is compatible. Excellent. So the OSI model isn't just a model to make networks compatible. It's also one of the best ways to teach people about networks. Keep this in mind since I'll be referring a lot to the OSI model. It's very helpful and useful as well. So we have a set of layers which are very important. We have the physical layer, layer one, data link layer, layer two, and so on. We have the network layer, the transportation layer, the session layer, the presentation layer, and the application layer. Usually they have a joke that when there is a problem with the between the seat and the computer, we have a layer 8 connectivity problem or issue. That is like a geeks joke. We have a layer 8 problem. That's basically referring to the user, which is me. So just for you guys to be understanding a little bit, but that is not part of the real layers that we're covering so far. So we have physical, data link, network transportation, session presentation, and application layer. We can have this anagram. All people seem to need data processing. This is the OSI, which has 7 layers: application, presentation, session, transportation, network, data link, and physical layer. There is a way to remember. This is a way to remember the layers, but please do not use this in a job interview. They need to know that you have knowledge about the 7 layers and you're familiarized with them. But the acronyms and these anagrams, they are not needed in a job interview. So just be careful about that. So let's start with the physical layer and what does it do. This layer describes stuff like voltage levels, timing, physical data rates, physical connection, and so on. Everything you can touch, since it's physical. Data link. This layer makes sure data is formatted. Uh, the current way takes care of error detection and makes sure that data is delivered reliably. This might sound a little bit vague now. For now, try to remember this is where Ethernet lives, MAC addresses, and interaction with the switches, layer 2 devices. Ethernet frames are on the data link layer. What about the network layer? If we come back to this, we have talked about the physical and data link, and then it comes the network layer. Now, remember routers. We're talking about routers. This layer takes care of connectivity and path selection, routing. This is where IPv4 and IPv6 live. Every network device needs a unique address on the network. Let's move on, and now we have transportation layer. The transportation layer takes care of TCP and UDP. Those are protocols. TCP is a reliable protocol and UDP is unreliable. We will go deeper into those protocols later on during this bootcamp course. But for now, just keep in mind that transportation layer takes care of transport. Where you downloaded this book from the internet, the file was sent in segments and transported to your computer. Let me just move on with the next layer, and we have the application presentation and session layer. So the session layer takes care of establishing, managing, and termination of sessions between hosts. When you are browsing a website on the internet, you are probably not the user of the web server hosting that website. This web server needs to keep track of all different sessions. The presentation layer will make sure that information is readable for the application layer by formatting and structuring data. Most computers use ASCII table characters. If another computer would use another character like F, E, B, C, D, C, I, D, I, C, then presentation layer need to reformat that data, the data, so that both computers agree on the same characters. And finally, we have the application layer. Here are your applications: email, browsing the web, HTTP, FTP, and many more. Let's go ahead and remember, people do not need to see Pamela Anderson. That's another acronym, anagram where you can actually remember the 7 layers. Let me just share with you something important that I've been keeping here in secret. Now you have it available. We have different data units. In the application, we have data in the presentation and the session as well. In the transportation, we have the PDU call segment. In the network layer, we have packet or datagram. In the data link, we have the frame. And finally, in the physical layer, we have bits, zeros, and ones. These are some examples, and let me just, maybe I can just increase the size of this website. Let me see if I can do it real quick. Okay, perfect. So, application layer, we are talking about the user interface, protocols, popular protocols, HTTP, FTP, TFTP, Telnet, SNMP, DNS. Those are examples of protocols. And please remember, if you're doing a job interview, you have to familiarize with them, memorize them, learn it by heart, because they will probably ask about this information in a job interview. Presentation, data representation, encryption, and decryption. Some of the popular protocols in the presentation layer are video, WMV, AVI, bitmap, JPEG, JPG, BMP, PNG. Audio, we have WAV, MP3, WMA. Those are some examples. Let's go with the session layer. Remember, the PDU or protocol data unit is data. Some of the popular protocols are SQL, RPC, NetBIOS, and those are some names per se. In the session layer, this is what happens: set up, monitor, and terminate the connection session. Let's move on to the transportation layer. Flow control, buffering, windowing, congestion avoidance helps prevent the loss of segments on the network and the need for retransmission. The TCP connection-oriented reliable and the UDP connectionless unreliable. The PDU for this layer is called segment. Now, moving on, we have the network layer, path determination, source and destination logical addresses. Some of the popular protocols that we have here are TCP, connection-oriented and reliable, UDP, connectionless, unreliable. Segment is the PDU for this layer. And that's it. Network layer. We have covered pretty much everything until the transportation, right? Remember, what is the function and description of the transportation layer? Do you guys know? Flow control, buffering, windowing, congestion, avoidance. It helps to prevent loss of segments on the network and the need for retransmission. The network layer is the path determination, source and IP, source and destination logical addresses. You have also the router devices, layer 3 devices. Some of the popular protocols are IP, IPX, AppleTalk. Packet and datagram are the PDU in this specific layer. Now, if we move down and we get to the data link layer, also called layer 2, we have the PDU, which is frame. We have devices like hop, switches. Actually, is switches and bridges because the hop is a physical device. It will be the layer 1. So be careful about that. Layer 1, hop and repeaters. Layer 2, switch and bridges. In the physical layer, we have bits, zeros and ones. Those are the PDU for the physical layer. Now, let's go over the function of or description for these last two layers. The data link layer, physical addresses, includes layer 2 addresses. Upper layer, LLC, logical link control. Lower layer, media access control, MAC. Some of the popular protocols are LAN, WAN, HDLC, PPP, frame relay. And remember the PDU, it was frame. Finally, we have got to the physical layer description, which is it encodes and transmits data bits, electrical signals, and radio signals. All right, that was a little bit intense, but you have the idea. You are becoming familiar with the layers of the OSI model. Let's move on with this book. And let me just escape from here and improve the size a little bit. Let's talk about a real example of data transmission. You're sitting behind your computer and you want to send a connection and access Facebook, for example. You want to access Facebook. So you have to send a notification in order to access the web server. Let's say you use a reliable protocol called TCP. And in order to get to the web server, you're using TCP and HTTP connection. You get to the server reply back, and you get your package and your information. So that's a little bit of how the different protocols are connected from your original source to the destination. We will take a look at this in another example. Let me see if I can open the guide. Maybe I can show you a better example of this before we talk about the TCP and IP stack. This, I should have like an example of the communication of the different layers. Let's take a look at this one. There is another anagram. People do not throw sausage pizza away. So another way to remember the layers of the OSI model. Okay. So every time you're moving from the application to the physical and from the physical to the applications, you are using PDUs, also called headers. You have the different PDUs, which are, in this case, segments, frames, and bits. We went over that before. Oh, this is the example. We are going to look at this one in a moment. So the PDUs are application presentation and session, we have data. For transportation, we have segment. For network, we have packet or datagram. For data link, we have frame. And for physical, we have bits and zeros and one. So let's take a look at how the communication happens. This document must be sent from Charles' office in France immediately. Henry, English. Yes, sir. Your document should be sent as an email, so I will send you as an MP, as an MTP. We are starting at the application layer. Our partner is French, so I have to translate it into French and style it into email format, presentation layer. I would call them first to make sure they are available. I also monitor during transmission and terminate when finished. I can control the speed when transmitting via flow control. I will also break our mail into small chunks or some parts. Require our partner to acknowledge after receiving it. That is session layer. Layer transportation layer. Let me add our office address and partner address on each part. Network layer. Let me add our IP unique on the world and the local post office ID in each part. It helps mailman deliver it easily. Data link layer. The email is urgent, so I will send it via plane. The physical layer. Hey, I received something. Yes, it is for us. I will check for errors and I will fix it. So you see the communication of layers, physical layer, data link layer. They're doing their job. They're doing their thing. Uh, network layer. It's from Henry. Transportation layer. I will reorder each chunk or each part of the correct position so that it can be understood and also tell them it has been received successfully. Session layer. The mail has been received, so I will terminate that connection. Session layer, we have the presentation layer. Let me format it so in a way our boss can understand it easily. Application layer, it's a mail, so I will use suitable services for it. Charles in branch. Well done, my assistants. Okay, so we have covered the communication between the different layers in this real life example of an email being sent from an English office to France. That's the first example. Let me see if I can find another example for you guys so it's easier to understand because I wasn't that much clear in the first. I was just giving you the main idea, but I want to find another better example about this. So give me just a moment, please. Let me just look for that. So we're going to look for the TCP IP. Where's the OSI? Do you guys see it there? TCP IP OSI model. Hmm. Hmm. Introduction to the TCP IP. I don't see the OSI. Oh, there you go. There is. We have application presentation. And if you look at the other one, it's actually the DoD model. We have processes and application, transportation, internet, and link. There is also another one called the TCP stack. We will go over that one in a moment, but I'm trying to find a real life example. Just in case I don't find it, I will go ahead and go to GTP chat and maybe ask him about that example that I want. Let me just do that. Give me just a moment. Let's go ahead and do that for a moment. So let's imagine. Let us imagine we have a communication from an end user to access Facebook. Comma. Behind the scenes, how does the OSI model works? Now we're trying to figure this one out because it's a little bit tricky and different, but let's take a look at the different layers and the way it works. Okay, so now we have it more clear. So you enter facebook.com on your browser. The browser is an application. It uses HTTPS to request the Facebook page. A DNS is also triggered here to translate the human-friendly name facebook.com into an IP address. Moving forward, we have the layer is actually the layer 6. Let me improve the size a little bit. So, ensures data is formatted both sides. Understand. We have encryption, DLS, and SSL. We have certificates in the browser. So it's an official website and a secure website. And we have these certificates. And the data compression and encoding is happening. Moving forward, moving on. Layer 5, session. A session established between your browser and the Facebook's servers and handles dialog control, when to send and when to wait. Think of it like setting up a stable communication channel before exchanging lots of information, conversational channel. Layer 4, TCP is used for connection-oriented and reliable. TCP segments the data, assign sequence numbers, ensure delivery is error-free. If packets are lost, TCP transmit them, retransmit them. Ports are used. For the client, for example, a random ephemeral port can be 52345. The server standard HTTPS port will be 443. We have arrived at layer 3 network. Data is packaged into IP segments. IP addresses are source. Your device and destination Facebook servers. Routers along the path decide the network route across the internet to reach Facebook's data center. Layer 2, data link, packets become frames. We are using MAC addresses so that frames know how to move inside the local network, the LAN. You guys remember the LAN? We saw a little bit in previous lessons about that. It's a small network connection. Your local home office, your local home connection is an example of LAN. We have connectivity between your PC, the switch, and the router. Ethernet and Wi-Fi protocols work here. Finally, we arrive at the layer 1 physical. The actual bits 1 and 0 are transmitted over your medium. Copper cable, electrical signal, fiber optic, light pulses, and Wi-Fi, radio waves. On Facebook server, receive your request. They respond with the request data, HTML, CSS, images, etc. The entire process runs in reverse order from the layer 1 to the layer 2 until you see your Facebook feed rendered in your browser. In short, you click Facebook, the OSI layers work invisibly, the data flow across the internet, Facebook loads your page, your website in your computer screen. And this is the process of how does the different OSI models work in real life when you're accessing Facebook. Pretty much the same process happened in all websites. Like example, we are accessing google.com, and it's pretty much the same process. Very similar process. Now, let's go and return to how to master CCNA. And let's talk now about the TCP IP stock. So this is just terminology, and don't mix up talking about IP frames and Ethernet frames. Okay, so in layer transportation layer, we talk about TCP segments. In the network layer, we talk about IP packets, and the data link layer, we talk about Ethernet frames. Those are the different PTUs, and we have shown more before. Besides the OSI model, there was another organization that created a similar model which never came quite as popular. However, for your CCNA, you'll need to know what it looks like. It's called the TCP IP stock. It's similar, except some of the layers are combined and have different names. We have the application layer covering the last 3 layers that we went over before in the OSI model. The transportation layer is the same. The network layer in this case is called the internet layer. And then we have the data link layer and the physical layer in a single one. We have the network access layer. So that's a little bit about the difference. Maybe you can see the difference here. Okay. I'm not allowed to write in this book for now, but maybe there is a way I can write. Give me just a moment. So this first layer, they are combining together, they're the application layer. Then transportation is pretty much the same. Network, it becomes internet. Data link and physical layers are the network access. So pretty much they are the same, but there are some important changes here where you can actually see, maybe I can change to a green color for now. The first 3 layers, those 3 layers, maybe instead of using a pencil with colors, I want to change to another color. Maybe I can just type the information. So we have 3 layers over here, 3 layers. I'm wondering if there's a way to change the color to another one, maybe black. Perfect. And then this one is pretty much the same. This one, it changes a little bit. And these are the last 2 layers. They are called the network access layer. So that's pretty much the difference between the OSI model and the TCP IP stack. Basically, it's the same idea. Let me just erase the screen because I forgot to do that. Let me just clear the drawings. It's basically the same idea, same model, except which there are some changes, some names changes, some of the layers changes, but you have become familiar with that. So let's move forward and let's go to Wireshark organization so you can download and install Wireshark. I'm going to show you how to do it. Let me just download it I have Windows. So I'm going to download it right now and install it. It will take a couple of minutes or seconds. And let's talk about it in the meantime. What is Wireshark? How does it work? So it's basically a software or a tool that allows you, it's a free software that allows you to analyze packets and understand the way of the packages they communicate, the different protocols of the OSI model. So it's very useful and it's actually friendly. We are going to learn a little bit about it right now. In the meantime, while we're downloading and installing Wireshark, let me see if I can download a capture. Hopefully it will still be available. If not, I will figure out a way. Let me see if there is a recommendation in the book. Let me just go back to the book real quick. There are some examples for web server. So let's look at a similar example in a web server capture. Let's see. Which one? Server. And I'm trying to find one that might be very useful for us. Which capture can we use? Let's do not get too much complicated. Let me go ahead and just do for let me see. It doesn't recommend a specific one. This is an example of a capture above. Okay. HTTP. So let's look for HTTP here. Give me just a moment. HTTP capture. Maybe I can look up that specific name, HTTP underscore gzip. Let me see if I find it. Nope. Oh, there you go. Gzip. There you go. So I have the capture, I have the program. Let's install it. Let me go to download and install that. It is pretty much easy. There's this program. It's just clicking next, and so on. Let's add a desktop shortcut and click on all of them. Next. Pretty much is, let's keep everything installed there. Okay. Use this one, uninstall any undetected use caps. Okay, let's select all of those so you have the most updated information and the most updated options there. Now, it looks like it's taking a little bit of time. Let's be patient. Let's be real patient. And in the meantime, let's go back to the book. So the server in the picture above is captured from a computer requesting a web page from a web server. I didn't capture this one myself since the Wireshark website has a lot of good example captures. So I already shared with you, and I will share this in the class where you can actually download these examples and everything. Pretty much you can see the protocols, the ports, the Ethernet information, the Internet protocol, the frame, the transmission control protocol. This is the data link layer. Then we have the network layer for the internet protocol and the transmission control protocol. This is the transportation layer. We're going to see some of the content, for example, the frame information, the Ethernet information, the internet protocol, the different source and destination IP addresses that we will go over them more depth into them during this course and bootcamp. But just you're getting the idea pretty much. Okay, Wireshark samples captures, we went over it. And there is a movie that is recommended. Let me see if it is available. It's actually called The Warriors of the Net. You can download it in any language. And you can choose the one and just download it and become familiarized. How does the package move along? How they work? I will also share this website with you guys later on. Okay, so let's see if we have Wireshark installed successfully. Wireshark. Let me just open it. Hopefully it will be working successfully. What is going on? Okay, wait. It wasn't installed yet. It is still taking some time. So let me just pause the recording for a moment and I'll come back as soon as it is completely installed and finished. Okay, it is still not completed, but in the meantime, while we're waiting for the installation, let's go over this explanation. So once we are able to open it, let me just stop sharing video so we can focus on this. Once we have the program, it will open a .cap file and it will have seen this information, TCP protocol, HTTP protocol, all that communication that happens between source and destination. And that's pretty much it. You will have the source, the destination, and the protocol. We will be able to see 10 IP addresses or more, basically source and destination IP addresses, and the destination IP address, it will be shown the protocol related or connected to those specific communications. That's pretty much it. Okay, then we will be able to open each of the captures and analyze them in depth. And you will be able to see frame, Ethernet, inter-protocol information, transmission control protocol. Okay, there you go. Once you click on it, you will have more information to analyze, to study, and to understand. The frame, the Ethernet, the checksum that checks for error detection. We have talked about it, not much in depth, but basically the checksum is related to error detection. Remember that. What does it mean? This computer is carrying an IP packet. Let's see the content. We have the source, the destination IP address. Let me see. How are we moving along with this install? Let's just agree and install it real quick. Hopefully it will be over pretty much soon. Taking a little bit of time, but it's getting there. Okay, and you will be able to see the header length, 20 bytes, the version of the internet protocol, the differentiated service field, the identification, the flags, the time to leave. We will go into that, but it's basically how long a packets live in the internet. That's a description. I'm going to look into ChatGTP so we can have a better description of that in a moment. Let me see. I agree and install. I'm trying to install this program so we are able to just run it successfully and take a look at the packages. So what is TTL and how does it work? Let's just ask. What is TTL in networking terms? And how does it work? It's a pretty much simple question, but we want a deeper understanding and a better description. ETL stands for time to live. It's the field in the IP packet header for both IPv4 and IPv6 that determines how long a packet can live or travel across the network before being discarded. Think of it like an expiration date for packets. So they don't wander around the internet forever if something goes wrong with routing. How does TTL work? Packet creation. When a device like a computer or a phone sends a packet, sends a TTL value, common default is 64, 128, or 255, depending on the operating system. Hop by hop decrement. Each time a packet passes through a router, a hop, the TTL value decreases by 1. TTL 0 if um, a packet's TTL reaches 0, the router discards the packet and usually sends back an ICMP time exceeded message to the sender. This prevents from looping endlessly due to routing errors. Why is it TTL important? Loop prevention. It keeps the network healthy by avoiding the infinite packet circulation. Troubleshooting tools like traceroute or tracer rely on TTL. They intentionally send packets with small TTL values to make routers along the path respond, revealing the router step by step. Performance and security. Some systems analyze TTL to detect spoof packets and abnormal traffic. We have a quick example to close this chapter. Your PC sends a packet with a TTL of 64. It passes through 5 routers. Each router decrements TTL by 1. Now it's 59. If the destination reached before TTL hits 0, all good. If the routing protocol happened and the TTL, if routing loops happen and the TTL hits 0, the packet gets dropped, avoiding chaos. In short, TTL is a safety mechanism to prevent immortal packets and also a very handy tool for network engineers when diagnosing routing paths. Okay, let me activate the camera so you can see me. And let's see if finally we have this installed. I will do it later. It's asking me for a reboot, but I just want to test it. Wireshark. Let me see if the application finally is there. Okay, you go to your file that you have downloaded from the other website and you have to import the file. Let me see if there is a way to import this file. Open. Let me just go to downloads. And let me just see. There you go. Now we have the information. Let me stop sharing the video for a moment so we can concentrate on this. You guys are seeing the screen? Okay, we have the source and destination IP addresses. You have the different communications. We have the protocols. Let's check one of them. Let's start with this one, the first one. And you can see all this handy and useful information. It is pretty much amazing how you can see the encapsulation, the information about the frames, this frame number related to this specific event, and packet capture. You can see the sequence number over here, the windowing, the LAN, the connection of the different ports and the communication happening. Let me see if I can find more useful information there. You have the IP before the source. There's an Apple computer connected to this device, a Kingston Technology destination. You have the MAC addresses. This is the correct format for MAC addresses. The Internet Protocol version 4, the header. And we talk about the TTL. Look at this one. It's 64, actually. We talk about that example. We have the source, 192 and 168.69.2, and the destination, 192 and 168.69.1. You have the destination port, which is equal to 80, and the source port, which is equal to 34059. transmission protocol. Let's take a look at this, the last one there. You have the acknowledge number, the sequence number, the checksum that usually works checking errors within the packet. If there are errors, you have the conversation. I'm trying to see if I can find the TCP protocol more in depth. You can see a TCP segment related to this specific transmission protocol. It's actually right here, transmission control protocol. That is the TCP protocol, and we have interaction between the source and the destination protocol. Usually there is a default standard port for TCP. So let me look it up real quick. Let me just ask the question. What is the standard protocol for TCP? Okay, so take a look at that. We have HTTP, the default port is 80. HTTPS, we have 443. FTP, we have 21. SNMP, we have 25. IMAP, 143. And let's look it up. That TCP is actually 53 for the DNS, but I'm looking for the specifically for TCP. So usually it can depend on the communication. I don't see it there. You have the three-way handshake. I'm wondering if it is not attached on a specific port alone. Okay, so it says that the transmission control protocol doesn't live alone. It's hosted on a fancy network party and is using different applications and different ports. So maybe it is not using a specific port per se. It depends on the different applications to work. So it means TCP doesn't have an assigned port. Let's just ask the question again. Does it means TCP does not have a specific port assigned? I'm trying to figure out because I remember there was a port 179, but it's probably related to something else. Okay, so it depends on the application. Okay, so 179 port for which application works? For which application or port works? I just want to clarify everything here. It's actually for BGP. When you're using the application for BGP, connecting to the different service providers, you are using the TCP port 179. So we have pretty much discovered that TCP will have different ports depending on the application that it uses. Let us create a Word document with all TCP information discussed today. Maybe that will be very useful for us if we have that document and the information about the TCP, so everything is getting clear for us. It will probably take some time. There you go. I want to share this with you guys, but maybe I can share most of this information, at least the notes that we have covered regarding this port, the TCP protocol. And remember, it will use different ports depending on the application that it uses. So we have to be attentive and make sure we acknowledge that. Let me see if I can save this in my computer. Downloads. It's taking a little bit of time. Let me just close it. Well, let me share this in. Let me go to the course. I have to close Wireshark. Let me just close it and try again. Pretty much everything is here. I'm going to see if I can share most of these documents with you. Wireshark is easy. You just go to the official website and download it. But maybe I can share this packet and then the guide that we have created, this one, and also the book, How to Master CCNA. That will be useful for you guys to have it. Okay, I think we have nailed it. Let me just share the video again so I can say goodbye to you guys. We have pretty much nailed the class. It's been an amazing lesson with a lot of learning, a lot of uh, teaching, and I am the one that learned the most about this lesson. So I want to say congratulations if you have get to this point. Uh, Keep taking notes. If you have to go over the lesson and class and review everything again, go over it as much as you can. I will share most of these documents. I will share also, what else? What else? Maybe I can do a zip file and just share everything in a zip file for you guys about this lesson. I want to share the website, so you have the websites available. That's pretty much. So, boys and girls, I will see you at the Climb of Success. Take care. I will see you around. And until next time, my name is Cesar Alonso. It's been a pleasure working with you today and teaching you a little bit about network applications and the OSI model and the TCP IP stuff. I'll see you around. Goodbye. Let me just end this lesson.